previous class we discussed about gravitational potential energy. Now in chapter number 6, work, energy, power, we have studied that potential energy is energy possessed by a body by virtue of its position or the configuration. So ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ತನ್ನ ಪೊಸಿಷನ್ ಇಂದ ಕಾನ್ಫಿಗರೇಷನ್ ಇಂದ ಎನರ್ಜಿ ಪಡ್ಕೊಳ್ತಾನೆ, ಅದನ್ನ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅಂತ ಹೇಳಿ ಕರ್ತಿದ್ದೀವಿ ನಾವು. So here we are going to study gravitational potential energy. Now potential energy is energy possessed by a body or energy stored. Energy possessed by a body by virtue of its position is called potential energy, and it is also a stored energy. We have given some examples: energy stored in a reservoir, energy in the case of bow and arrow that we have studied in the previous class. Now here we are going to study gravitational potential energy. For that one, we will consider the earth. We have an earth of mass me and has a radius re. Now I am having a point object. It is at a certain height h1. The point object is having a mass m. Okay. Consider the earth. Above the surface of the earth we have a point mass which is at a height h1. Now we considering the point mass very nearer to the surface of the earth such that acceleration due to gravity is constant. Now because of this position, this point mass has a potential energy. Now I am going to move this one to the new height h2. Now h1 is height of the point mass from the surface of the earth. Now I have to lift this mass, point mass, from h1 height to the h2 height. This is h2 height. What has to be done? Work has to be done. Work has to be done in lifting from the height h1 to the height h2. Now difference in work, that is work done in moving the point mass from h1 height to the h2 height, that I will write. Work done in moving from h1 height to h2 height is equal to force multiplied by the distance or displacement, that is h2 minus h1. Now what is the gravitational force? It is m into g, h2 minus h1, force into displacement, that is work done. So therefore I will write it is m into g h2 minus m into g h1. Now this is the work done. M into g into h, it is the work done. I will write this as work done at the final position minus work done at the initial position. Now this m into g into h is called gravitational potential energy. This is called as gravitational potential energy. Therefore general expression for work done is equal to m into g into h. Now this work done is stored as potential energy of the system. It is stored as potential energy of the system, and hence the general expression for potential energy is gravitational potential energy, U is equal to m into g into h. Now we are using this formula only when this g is assumed to be constant. That means if this height is very close to the surface of the earth, so that the acceleration due to gravity g is taken to be constant. But in some other cases, this g is not at all constant as we move upwards. If we move above the surface of the earth, the G value goes on changing, therefore potential energy is not at all a constant. There is one method of finding the gravitational potential energy. Now this is using only when G is taken as constant, that is the object is very nearer to the Earth's surface. Now the another way of finding the gravitational potential energy is, now we have a point mass which is at height h1. Now what is the distance of the point mass from the center of the Earth? The distance is equal to, we have to add radius of the Earth plus h. Now onwards let me call it as r. The small letter r ಅಂತಂದೇಳಿ ಕರೆಯುವ. Now what is the gravitational force between the two? The gravitational force between the two is given by the universal constant, gravitational constant G, capital ME, mass of the Earth, small m, it is the mass of the point object, divided by square of the distance, RE plus H whole square. Here we are taking it as small r square. Let me take it as small r square. Okay. Now, the work done in moving that point mass from height, here we have taken h1. So if you change it to r1, from the height r1 to the r2 height, that work done is obtained by integrating the above formula. Now work done is force into displacement. Therefore we are integrating this one, force with respect to dr, force into displacement. Here we have taken displacement as r, that is dr. Now here we have to integrate from r1 height to r2 height. So therefore that is equal to integral r1 to r2. Now substitute for the f, it is g me m divided by r square into dr. We know the integral formula. The integration of x to the power of n with respect to dx is given by x to the power of n plus 1 divided by n plus 1. By using that relation, if you integrate this one, now here G, universal gravitation constant, taken out, me, mass of the Earth, it is a constant, taken out, m, it is the mass of the it is the mass of the point object, it is also a constant. Only we have to integrate this one from r1 to r2, 1 by r square into dr. By making use of this formula, 1 by r square, if I take r square to the numerator, what I am going to get here, integral r to the power of minus 2, because r square is in the denominator. If I take it to the numerator, it becomes minus 2 with respect to dr is equal to, by if you use this formula, it is minus 2 plus 1 divided by minus 2 plus 1. If you simplify that one, it is r to the power of minus 1 divided by minus 1, or it can be taken as minus 1 by r. That is the integration. Therefore, this work done is equal to G me m minus 1 by r with the limits r1 to r2. Okay. So I will continue here further. Therefore, this work done is equal to, applying the limits, if I take the minus sign, G me m, first upper limit 1 by r2, lower limit 1 by r1. Now this amount of work done in lifting the object from r1 height to the r2 height is stored as the potential energy of the system, gravitational potential energy between the Earth and the point mass. Okay. If I choose R1 is equal to some point or infinity, if I take it as infinity, and R2 is equal to R, then the above expression becomes minus G me m 1 by R2 becomes it is R, 1 by infinity is 0. Now this is the expression for gravitational potential energy. So minus G m divided by R. So remember here what is R? Now R is taken as capital RE plus H. Remember that one, capital RE plus H. Now we will define gravitational potential energy. So it is the work done in displacing the object from infinity to that particular point. ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆಯೋ ಆ ಪಾಯಿಂಟಿಗೆ ಇನ್ಫಿನಿಟ್ ಪಾಯಿಂಟ್ ಇಂದ ಆ ಪಾಯಿಂಟಿಗೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಯ್ತು ಹೇಳಿ. ದಟ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ಸ್ಟೋರ್ಡ್ ಆಸ್ ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಫ್ ದಟ್ ಸಿಸ್ಟಮ್ ಅಂತ ಹೇಳಿದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಮಾಸು ಮತ್ತೆ ಅರ್ತ್ ಆಗ್ತದೆ ಇಲ್ಲಿ. Now we will define potential. That is denoted by. Now this is potential energy. Now this is potential. Now look here, in the potential energy equation, if I take m is equal to 1, small letter m is equal to 1. So if small letter m is equal to 1, then what I will get? So U becomes V, that is we call it as potential minus Gme divided by R. Now this is gravitational potential. Now how you define gravitational potential? It is the potential, gravitational potential at a point is, it is the potential energy at that point of a unit mass. It is the potential energy of a unit mass at that point is called potential energy. Or in other words, gravitational potential. Now we will define gravitational potential at a point is the potential energy of a unit mass at that particular point. Or in other words, we can define the work done in moving or displacing a unit mass from infinity to that particular point is called gravitational potential energy, gravitational potential at that point. Now this is potential energy, it is the potential. Difference ಇಷ್ಟೇ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಮಾಸ್ ಅನ್ನ ಇನ್ಫಿನಿಟಿಯಿಂದ ಆ ಪಾಯಿಂಟಿಗೆ ತರಬೇಕಾದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಯ್ತು. ಇಲ್ಲೂ ಅದೇಯ, ಆದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಮಾಸ್ ನಾವು ಯೂನಿಟ್ ಮಾಸ್ ಅಂತ ತಗೊಳ್ತೀವಿ. ಎಂ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಯೂನಿಟ್ ಆಗಿರ್ತದೆ, ದಟ್ ಇಸ್ 1 kg ಆಗಿರ್ತದೆ. ಆವಾಗ ಆ ಪಾಯಿಂಟ್ ಮಾಸ್, ಆ ಪಾಯಿಂಟ್ 1 ಯೂನಿಟ್ ಮಾಸ್ ಅನ್ನ ಇನ್ಫಿನಿಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಂದ ಆ ಪಾಯಿಂಟಿಗೆ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಯ್ತು, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಷಿಯಲ್. Now we will solve one problem. Find the potential energy of a system of 4 particles having equal masses placed at the vertices of a square of side L. Also obtain the potential at the center of the square. So they have given 4 particles of equal masses. They are placed at the 4 vertices of a square of side L. Now we have to calculate the potential energy, and also we have to calculate what is the potential at the center. Now solution. Now we are having equal masses. Now we will work out what is the potential energy between the two masses. These two, they are separated by a distance g. The potential energy for a single pair of masses is given by the formula minus capital G mass of the first particle or object m, mass of the second object, that is m, divided by the distance between the two, that is L. Therefore, U is equal to minus of G m square divided by L. Now, this is for the first and the second particles placed at 2 points. If I take this as A and B and C and D, then you can write this as AB, AB. We can write like that. Now, this is the gravitational potential energy between 2 point masses separated by distance L. The same is true for the B and C. Same is true for the C and D. And same is true for these two. That means we are having 4 pairs, that is AB, BC, CD and AD. Now, all the pairs are having the same gravitational potential energy. Therefore, potential energy for 4 pair of particles, objects along the side ಅಲ್ಲಿ 4 pair ಇದೆ. So, ಅದರದ್ದು potential energy sides ಅಲ್ಲಿರೋದು is equal to minus 4 G m square divided by L. ಯಾಕಂದ್ರೆ ಎಲ್ಲದು ಈಕ್ವಲ್ ಇದೆ, 4 ಪೇರ್ದು ಆಡ್ ಮಾಡಿದ್ರೆ 4 ಬರ್ತದೆ. Now we are also, along with that one, we are also having 2 pairs of point masses along the diagonal. Diagonally 2 pair of point masses ಇದೆ. Now Pythagoras theorem ನಾವು apply ಮಾಡಿಕೊಂಡು, if I calculate what is the length of the diagonal, so this AC square is equal to, it is L square plus L square ಬರ್ತದೆ, that is 2L square ಬರ್ತದೆ. Therefore AC is equal to root 2 into L ಆಗ್ತದೆ. Pythagoras theorem ಅನ್ನು apply ಮಾಡಿಕೊಂಡ್ರೆ. Now these are also having the same, they are also, those diagonals are also having the same length, that is 2 root 2 into L, root 2 into L. Therefore, potential energy of the pair of particles along the diagonal, which are along the diagonal, equal ಇರ್ತದೆ. So ಅವನಿಗೂ ಅಷ್ಟೇ minus of ಎರಡು ಪೇರ್ ಇರೋದ್ರಿಂದ I am writing it as 2 G acceleration due to universal gravitational constant, mass of the two m into m, that is m square obviously, divided by the length, the distance, length of the diagonal, that is root 2 into L. Now this is the potential energy for a pair of particles along the side. They are having 4 pairs. Now this is the potential along the diagonal pair of particles. We are having 2 diagonals, therefore we have taken as Q. Therefore total sum of these two, minus 4 G m square divided by L, minus 2 G m square divided by root 2 into L. If I take the common things here, common ಏನಿದೆ ಅದನ್ನು ಹೊರಗೆ ತಕೊಂಡ್ರೆ, therefore total energy is equal to, now minus of 2 is common here, G m square L is common, minus 2 G m square divided by L, now 2, since we have taken minus sign outside, therefore here it is plus 1 by root 2. If I using the calculator and if I use the calculator and U is equal to minus 5.41 G m square divided by L. This is the gravitational potential energy for this system. So in total we are having 6 pairs, 4 pairs along the side and 2 pairs along the diagonal. Now we have got a center O. Now we have to calculate what is the potential at that center. Center point alli potential is to find out ಮಾಡಬೇಕು. For that one I have to calculate what is the this side AO. Now AC is equal to root 2. Therefore, what is AO? It is half of that one. Root 2 L by 2. Or it is simply L by root 2. AO, length. Length is, this is L by root 2. Therefore, potential at the center is given by the general formula minus G m mass of that particle divided by L by root 2. So minus G m mass of the point mass of L by root 2. This is for single. Since we are having 4 point masses which are at the equidistance from the center, therefore I have to multiply it by 4. Since we are having 4 point particles. Now if I further simplify this one, now root 2 goes to the numerator, minus 4 root 2 G m divided by L. This is the answer for the gravitational potential at the center. Like this we are going to solve the problem.